Hello everyone. Let's start with our talk. Today we would like to share with you some of the problems we are facing in our day-by-day work when developing an Android app at the scale of a company such as Subito, and how we manage to approach them. So let me give you a little bit of context on what that scale means for us at Subito. So as Marco said, Subito is the leading Italian marketplace for finding things and sell things, whatever you want, actually. It has more than 11 million users each month and more than 6 million of published ads, so a lot of traffic and a lot of content. We have more than 300 people working on it, and around 100 people is just working on the product and tech department. Those people are divided into 6 teams. Each one of them is focused on a particular subdomain of the product. And speaking on Android, we also have 6 Android engineers spread on those 6 teams. They are working, of course, on the Android app that has more than 3 million downloads, 500K daily active users, and more than 4.5 stars on the Play Store as a rating. So today we're going to talk about 4 main challenges that we faced when trying to scale our Android app and how we approach them. The first one will be the features development. So how we made the features development straightforward and scalable with 6 teams working on the same app. How we manage all those features and how that we develop. How we manage to keep the UI consistent all over the app. And finally, how we made the process of distributing an up to 3 million users as painless as possible. So let's start and see how we manage to keep the development process scalable. The first problem you face with this team's division is that multiple Android developers are working on different stuff on the same code base in parallel. And of course, this makes the code ownership and responsibilities very unclear. So for example, who is going to be responsible for a particular change or a particular bug if found, or how can a team be autonomous in developing new features? Without having a clear code ownership, it's difficult to answer those questions. What we actually want is to make this ownership clear in order to easily associate a specific feature to a particular domain, and so to a team. For example, my team is working on the possibility to save an ad published on Subito as a favorite one, the little heart one. This is to consider an isolated feature that can be easily assigned to my team domain, and we will see how we handle that in our Android project. The second big problem is that when the code base grows, it becomes difficult to maintain good separation of concerns between multiple parts of the app, and you will end up easily with a mix of responsibilities coupled all over the project. What you actually want is that various pieces of code are decoupled one from each other, and that the dependencies are explicitly declared and clear. So it's essential to apply solid and other design principles also at a much bigger scale, not just between classes and small components. And last but not least, a big project means, of course, that build times are going to grow in time. And as Android engineers, we know that this could be a really big pain. For example, a clean build on our local machine could easily take more than 10 minutes to complete. So it was essential for us to find a way to maintain cached builds as fast as possible, so that the day-by-day development cycle is shorter enough just to not go crazy. Basically, believe me, when I say that having to wait more than a minute for just one line change is completely stressful, boring task. So let's dive in how we manage to achieve those 3 goals. Of course, the solution was provided by our beloved Gradle, and in particular, its support to modularization of project. As you know, it allows you to split your project in multiple sub-modules and declare dependencies one on each other. So thanks to Gradle modularization, we were able to declare a clear module ownership for each module, and a module can be easily assigned to a team that will own the module and be responsible for it. It decouples features. In fact, a feature or a part of them is isolated into a module with a clear responsibility, and we can explicitly declare dependencies. And also it helps with build times, since Gradle can parallelize your build and use different cores of your CPU to compile different modules in parallel. And also it can cache the build of a specific module. And it also gives us a lot of other benefits, such as test isolation and the possibility to cache the results. And in general, it gives us more flexibility on customizing our builds. Of course, it's not an easy task to split a big project into module, especially on an already very big project. So you have to define rules and try to be smart in finding a split strategy that better fits your needs. This is actually how we decided to do it and approach the problem. We have a base module app at the bottom of the dependency graph that could be virtually empty. Actually, it contains just the subclass of the Android application class. Then we have multiple feature modules, which the app module depend on, and that can be, of course, that can depend on each other, of course. And finally, we have a set of smaller core modules that contain code that is needed and shared between multiple features, such as, I don't know, networking, logging, or database stuff. So this division seems easy and straightforward, but it presents some challenges in defining how module should look like. For example, how do you maintain a clear separation between API and implementation of a feature? How do you make it work well with dependency injection? We use Dagger 2 and we heavily depend on that. How do you keep the build fast over time? It's not sufficient to just split code into modules to improve the build times. You have to pay attention on some key things we will see later. And how do you avoid having to write a lot of boilerplate to just create a new module? Let's go deeper in those challenges. So how did we manage to keep API definition and decouple from their implementation? We decided that a feature had to be contained in more than a single module. A feature for us is actually a folder. Gradle does not allow you to create nested modules, and it contains all the Gradle needed modules. The first one is the API one that contains all the exposed models and interfaces that can be used from other modules. And then we have the implementation one that actually contains the implementation and everything else you need in your feature. And of course, this is the direction of the dependency because the implementation is depending on the API to implement and use module. Okay, so this separation allows us to be very explicit and clear on what depends on what. Let's see an example. Consider the previous module, that is the module containing the login feature. And let's imagine that the login API module is containing some sort of router or a component that lets you navigate to the login wall. And the API implementation contains the actual page implementation that is hidden inside the module. Another feature could be a page showing the list of ads that the user published on Subito, that of course we want to be available just when the user is logged in. And of course it will need to open the login page if the user is unlocked. So it can easily declare, the implementation module of the user page feature can easily declare a dependency on the login API one. And in this way, it will be able to open and navigate to the login page without knowing anything about the implementation details contained inside the login. Actually, this structure and this solution gives allows us to have another advantage, that is to enable circular dependency between features that wouldn't be possible if the feature was contained just in a single module, because Gradle is forbid having circular dependencies, of course. So it's not particularly useful in this example, but let's imagine that the implementation of the login needs to in some way interact with the user page APIs, it can easily declare a dependency within the implementation and the API of the user page and use the code in that module without breaking anything in Gradle. Okay, next topic is Dagger. So how did we manage to make all of this work with Dagger? We are heavily depending on Dagger in our code base. So how we can manage to have the dependencies that are provided by the API modules to be injected into the implementations once without breaking the separation we achieved with this separation. To understand better how we achieve that, let's go back to the login example. And what we did was to introduce a third module named DI. And the purpose of this module is just to contain all the stuff related to dependency injection, such as Dagger modules or subcomponents. And it, of course, depends directly on the implementation, since it needs to know the real implementation of interfaces and stuff to be able to construct objects and inject them wherever they are needed. But how the next problem is how can Dagger be able to build a dependency graph if all its modules and subcomponents are spread all over other modules? That is actually the main purpose of the app module, since it will contain just the main app Dagger component. This way, the component can see all other modules just by setting the app module depending on all the DI modules spread all over features. And this way, it, of course, can create dependency and inject where they are needed. Okay, so let's spend some time talking about build times. So how did we manage to keep them faster enough? Because it's not sufficient, as I said, to just increase the number of modules to decrease the build time. You also have to keep in mind some aspects and make smart decision to on how to split your code into modules. And so when we started the process of splitting our code base, we of course realized that our project has a lot of code that can and should be reused in several parts of the app. So the temptation of having a big common module was very strong. But we realized that this module could be a very big obstacle in trying to keep the builds fast. The problem of this kind of module is that a lot of code inside them, with having a lot of code inside them, the chance of having the code change increases a lot. And this change causes the cache of other modules to be completely invalidated if all depend on that common module. So, for example, having a small change in the common module regarding, I don't know, a network class will invalidate both the cache of the common module and also the cache of all other features that depend on the common one, even if they are not actually using any network code. So to address this problem, we decided to completely drop and avoid the concept of a common module in favor of having multiple core modules. We call them core modules. And the key points of those core modules are that they should be as small as possible, self-contained, and that they should have a clear single responsibility. They are basically abstraction over framework and library. For example, you can have the core log module, network permissions, that is an abstraction over the permission system of Android, and stuff like that. And also another important thing is that since they are so small, the probability that they are going to change in the future is smaller than having a common module. So with those core modules, the features can depend on just what they need, selectively on what they need. So if the previous example occurs again, so a change in the network class happens, you will end up having you will end up having the cache of the core network and the features that depend on it cache invalidated, but not the other ones. So this way the build times can be faster. Last but not least, we realized that applying this strategy meant for us that the process of creating new modules becomes a task that you can do very frequently during your day-by-day. Consider that right now we have more than 300 modules and they are growing. So to make everything works, we need to make sure that creating a modules, it's an easy task and a painless one. So why I'm saying this? Because the process is actually composed of a quite big number of steps. You have to create the API module, you have to create the implementation module, you have to create the DI module, add all the needed dependencies, not just the one between those modules, but also the common ones that probably are going to be used by those modules. For example, DI, of course, will depend on Dagger stuff. The implementation one maybe will depend on Android. Maybe the API one could be a simple Java library. And so, of course, we didn't want to go through all these steps each time manually. So we decided to automate the process, and we created a Gradle task that, given a module name, we go through all these steps and set you up. It also adds your module names to the settings.gradle files so that Gradle can know about the new modules. And this way, we managed to achieve the goal. So creating new modules is easy and fast. Okay, then, so we talk about how we manage to make the process of developing new feature scalable. Let's see now with Dave how we manage them.
Okay, so thank you, Jack. Now let's introduce the second topic of the session. As Jack said, with our dimensions, the code base grows and grows as feature gets included. So we can now move out for a second from the concept of module and try to think at features instead. So we can start from the assumption that a feature is the result of development. So during this chapter, we'll cover how we manage those in Subito, considering the dimension of the product. Well, how can we keep feature supervision and management easy? There is a high chance that a project like this will get out of control if its management is not well structured. So we can say that we need feature management to be scaled as well as feature development. Now, considering we have in our hands such a high number of features, the chances as well that something weird could happen is amplified. So it's simply more statistically probable that we could end up with a bugged feature, for example, or a crashing feature, or with an A/B test that needs our attention because it's unproductive. All of this situation must be addressed quickly because it's probable as well that we encounter multiple of these problems as well that we all at once. So let's assume we realize we're having a bugged feature. For example, what we normally do is do the actual fixing of the problem and publish a newer version of the application. So we have identified 3 key steps of this process. The first one, so given time, the first one is when you realize you're having a problem in your application and you start working on it. The second is when you have produced a solution for that problem and you are ready to release a newer version of the application. And the third is when the app is available on Play Store, actually, to your users, and you can consider the problem resolved. But there's a fourth step that is the one when you have enough adoption on the newer version of your application. So is that the real moment in which the problem is resolved. Have you noticed this time frame? Well, this is a very dangerous place to things to happen because it can deal real damages in terms of users and worse money. Because, for example, if you have a payment feature on a payment page and the payment feature is not working, you are losing actually money. And additionally to this, it has an undefined duration. So you can fix your problem in a couple of hours and release a newer version of your application, but you can even have your incident last for a couple of days. So imagine having to perform this operation not for one, but with multiple problems at once. I think that the Liam Neeson approach is not enough this time. So in other words, we have to find a solution that scales as well with the number of features. So what we wanted to achieve here is to take immediate action right into the moment in which we discover the problem by remotely controlling the features. But how can we make this possible? How can this happen? Well, we decided to place behind each feature one or more feature toggles, where for us a feature toggle is an object that can modify a feature, that can modify, in other words, its behaviors, that can enable or disable a feature, and so on. But again, with a high number of features, we will end up with a high number of these objects as well. So we simply cannot afford to lose time with a complex or time-consuming implementation of these toggles. So we needed a simple and time-friendly implementation to make them a real helpful tool to manage our features. So we identified two key properties to make our implementation and usage simple. The first is type flexibility. So if I need a Boolean, for example, to manage my feature, I want my toggle to return a value of type Boolean to ease the usage of the toggle itself. And the second is service independence. So my implementation must not be aware of the remote service who's providing its value remotely. And I don't ever want to specify whether its value is provided from Firebase remote config, for example, or from another service. Now let's see an example we currently have in our project. We want to show you how easily we remotely control features. This is our AD detail in the Android application that shows detailed information about a published ad on our platform. Let's consider as an example that we want to remotely control the presence of a map view within this fragment. So we simply want to show the map view or hide the map view. The feature toggle implementation will be something like this. So as you can notice, we are extending the Boolean toggle superclass, which is part of the architecture behind our toggles. So if we needed instead a string toggle, we have currently in our project a string toggle, an int toggle, a JSON toggle, and so on. And then we have a default parameter, which is, I think, self-explanatory. When there is no remotely provided value, the toggle itself on the application will get this value or the latest value received from the remote service. And then we have a key, which represents uniquely the identifier of this toggle on the remote service. So, for example, if I need this toggle to be provided from Firebase remote config, I will go into remote config and define a toggle with this key and provide the actual Boolean value. And we have, in addition to this, a group, which we'll talk about later. And then, in addition to the implementation, we have the usage. As you can see, it's a one-liner, so I'm only defining map toggle.get, and I'm receiving the Boolean value. So it's very easy to use toggle in this way. As a final note, we have the possibility, thanks to some remote service, to add rules to these toggles. So we can specify a value for a certain condition, such as the application version. But when this is not possible, we usually define the toggle implementation by adding to the key the app version which introduces that toggle. So this way, if we need to change a behavior later, we can change the key directly with another version. Although this needs another release, so it's better to have a service that provides rules. Now, what if we need to reproduce a certain situation locally, maybe because there's a strange behavior occurring outside on production, and we want to know why? Well, we have a powerful tool in our hands to develop and test these toggles. Let's see how it works. We added an additional step when compiling that consists of a processor that first collects all the classes identified as feature toggle and places them into a menu whose UI is accessible through our debug application only. The result is this. As you can see, we have a list of toggles. These are the toggles we have in our project, and we have full knowledge overall their values. And when we tap on one of them, we can see this beautiful detail. And we are even able to override their value locally, so to reproduce the actual situation, which are causing an issue, and reset them to expecting again their value remotely. So we can return back to the official work of a toggle. And that's all from this topic. I'll pass the ball back again to Giacomo for the third topic of the session, which is UI consistency.
Okay, thanks, Dave. Okay, so let's take a little bit about UI consistency. And the main problem here is, as I mentioned before, having a lot of people working in multiple teams, which one of them with its own designer and Android development, means that you could easily end up with an app that is inconsistent from the UI point of view. For this reason, a common solution is to have a design system shared across teams that can be used by UX, UI people to design new features with a consistent UI, and also from developers to use them. Let's take a look at what a design system is actually. A design system is a set of rules, principles, and resources that define not only the identity and the qualities of a product, but also the way in which a team works and collaborates. What does that mean for us in a product and team at the scale we have? It gives us a lot of benefits. It allows us to scale both from the product and the team point of view. It gives us more consistency all over the app, since each feature should follow guidelines and rules defined by the system. It's a lot more efficient to iterate and create new things, since you don't have to reinvent the wheel every time you need something. And it also creates a single point of reference for teams when dealing with UI stuff, and help them to be updated and also aligned on design evolutions. So to gain all those benefits, our designers at Subito decided to develop a design system that is actually shared across all our properties, Android, iOS, and the web. They named it Cactus. They also gave it a pretty cool logo. They are a lot better than us in this kind of things. And they created it following the atomic principle. This principle states that a design system should follow some set of rules, and in particular, it should split designs of UI elements in different level of complexity, starting from a DNA that could be spacing, dimensions, colors, typography. And then you can use this DNA to create what are called atoms that are simple pieces of UI, such as buttons, labels, checkboxes, and stuff like that. Atoms can then be used to be combined to create slightly more complex pieces of UI that are called molecules. And then you go on combining them to create complex UI component organisms, they are called. For example, a card which represents an object in a list could be defined as an organism combined by multiple molecules or atoms. And finally, you can combine all of that, creating entire new pages. So what does it mean to have a design system from a developer point of view? It means that you can declare and develop once those UI elements and reuse them all over the app to obtain consistent UI. For example, we started on Android from the DNA definition. And so we created a set of shared resources, values, such as spacing, icons, dimensions, text styles, colors, stuff like that. And we strictly enforce the usage of those resources during PR reviews. Each time you actually open up PR that has some sort of layout, every time you define a dimension, a margin, or stuff like that, you should always be declared them using a Cactus resource. Otherwise, you will not get the approval. And to promote also and make easier to access those values programmatically, we create a set of extension properties over the Android resources class to be able to access them in a more clear and concise way. For example, you can simply write resources.spacing.md to get the medium spacing dimension. and you will not have to deal with all the resources compat, context compat stuff that kind of proliferated Android forces you to write. The following step was using those DNA resources to create atoms that are custom views, such as button text view as an input field, as I said before. And a key aspect of that is that they don't change until the definition changes in the design system. And also they are completely configurable both via XML and code in order to be able to match all the variation and state that are clearly defined in the Cactus design system. This way, every single possible case is already mapped into some sort of configuration of these views and is available for us developers who maybe are converting a design or a mockup into code, and we don't need to reinvent anything. When we then decided to use those Cactus atoms to create slightly more complex pieces of UI, the molecules, they are domain-specific pieces of UI in the sense that they are meaningful just in the context of Subito, unlike, for example, buttons that you can see in each API we use daily. And finally, you can use those custom views and combine them to create organisms. For example, if my team needs to create a list of ads that the user saved as favorites, it can take those custom views that represent a card of an ad and easily reuse them in a recycled view, and also decide how they should look like and which kind of data they are showing based on the specific use case. So all the work we have done to create those custom views once to follow Cactus guidelines allows us to spend less time developing UI that is shared all over the app, and at the same time we keep the UI, we are managing to keep the UI consistent in every screen, regardless of which team developed it. Okay, I think that's it for the UI part. Back to Dave, who will talk you a little bit about how we distribute our app to 300 million users.
Yeah, thank you. So we have covered a lot of aspects and strategies to be aware of when dealing with big Android projects. Now it's time to ship our application. Considering the amount of work and results we produce, it's the moment to keep an eye on the release process too. What's the optimal way in which we can ship the work of all teams in Subito? Since we have several teams and devs working on the same code base, we simply cannot afford to release a new version each time a new feature is ready to be shipped, because differently from web development, the release process on Android does not happen at instant speed, as you know. So we decided to follow the release train method to schedule releases each on a fixed period of time. This way, what's ready to be released gets included into the new version. But this only resolves the problem of synchronize all teams' work in a single release. We still release so frequently. And since producing a new release each time manually could end up being a very tedious and time-consuming process, we built a release automation pipeline in-house, which for obvious reason, Drakes agrees, it's way better at our scale. So having daily and release candidate builds, it is one of the pros of having an automation release process, because we can add additional blocks to the pipeline basically for free. So each day, in fact, our pipeline produces a daily APK built with a development variant made available to employees only. We usually use this kind of build to check with other teams like UX, for example, if we are going into the correct direction with our development. And additionally to this, when it's time to release, our pipeline produces a release candidate APK too, built this time with the release variant, again available to employees only. Differently from the dailies, we usually use RCs to review features with our stakeholders from a product point of view, or for example, to make a presentation to the company during demos. Both these distributions are available through the Firebase app distribution service. We have also found that define a figure to assign release responsibilities is also a good strategy for many reasons, such as having a point of reference when it comes to resolve problem in production. So you have only one person to look at when there is a problem. We call that figure a release captain. It is elected among us, among the Android team, at rotation each time a new version needs to be released. It's the main supervisor and responsible figure over this process, and its main duties are, let's see some. Well, first, trigger the release process actually by starting the pipeline. Second, update the release rollout. Note that we publish each new version with a phased rollout that is composed by 3 steps, where the first one is the result of the pipeline itself, in which the application is released in our open beta channel at full rollout. Sorry, we actually have around 10,000 users in our open beta pool. So this phase, and they are a lot, I think. So this phase helps us a lot finding the most critical bugs, such as the application crashing at startup, without expanding these bugs to the whole user base. Then in the second step, we promote the release to production at 25% of rollout, which are around 800,000 users or so. And in this phase, we can easily receive all the other newly introduced bugs if there are some. So we have still time to produce an hotfix without affecting the whole user base. The final step, instead, if we have a healthy APK, is when we update the rollout to 100%, which is more than 3 million users. Well, actually, this is 99.99% because we want to still be able to halt the rollout if something goes wrong. You know that on Play Store, if you place your application rollout at 100%, you have not anymore the possibility to halt it. And we want to still be able to provide an hotfix. So this is a trick we usually use. Another duty of the release captain is to observe and be the first to catch new crashes and problems on the observability platform. So it's the release captain actually is the person who must stay always on Crashlytics to check. And last but not least, after each team has fixed the eventual problems a new release has introduced, it must produce an hotfix release. Okay, so we have seen all from the release captain. Now I want to talk to you about one last thing. With so many versions out there, because we still release one time at a week, what if we want to deprecate versions remotely the same way we control features? Well, let's see why, and we would have the need to do this. Having a small user base that still have an old version of our application is expected because of the many versions we publish. An example could be that some of our users doesn't have automatic updates, or given we are on Play Store from 2012, it's only an historical problem. Actually, we are using in-app updates, which resolves a bit this problem. So we can update the application contents inside the application, actually. But we still wanted a last resource to take advantage of. We have created Deprecate, which is a deprecation service, which actually in Subito serves both Android and iOS, and it's made to remotely deprecate application version. This service comes with 2 modes of deprecation, the soft deprecation and the hard deprecation. The difference between the two is that both they show a message at application startup, which tells the user to update its application because it's old. And the soft deprecation makes still be able the user to use the application, actually. But the hard deprecation is totally blocking. So we use this mode very safely. Okay, we reached the end of the session. Thank you for your time. And remember that we are hiring, so keep in touch directly on the event platform and in our virtual stand for more information. Thank you again.